Gonna keep them rolling. So this is part of a series of various inventions that I have that I make open source. I'm not trying to market them. I'd rather raise everyone's boat instead of trying to capture money from other people. Because if you try to just capture from other people, then you inevitably lower the productivity of the whole system. And if everyone's trying to do a scam, then the only things your money will buy are scams. So just thinking systemically, you want to generate value for everyone because that's the best way for you to have access to the most value at the lowest price. And so one of the areas where that happens a lot is housing. Whenever you create artificial scarcity, the price goes up, especially for a basic need like housing. And so there's a whole lot of people who are banking on creating an artificial scarcity of housing. And if you solve that problem, then people can afford housing, which means they have money left over to get all their other stuff. So it actually boosts total economic productivity instead of just boosting wealth on paper. So there's lots of different ways that people proposed as alternatives to housing, and none of them have caught on because they make a categorical error. I was talking to a guy who makes cob houses, and he said it only cost $1,000, $1,000 in materials. He wasn't factoring in labor. He wasn't factoring in maintenance. He wasn't factoring in the lifetime of the materials, risk factors. These are all things that actual businesses have to account for, and he wasn't. Especially labor intensity and capital utilization. How often are you using your equipment? So here's an alternative made by a mathematician engineer that gets you a much higher return on your labor. Every hour of work that you do is producing much more value in housing for people. And you can monetize that without exploiting people because you're actually producing real value. So all my essays are on Medium. I've been shuffling them over to Substack. There's no paywall. Everything I do is open source. Here's the concept. When you build out of adobe, which is mud brick, that works great as long as you're in a dry environment where it's not going to melt in the rain. But there's a way to change your adobe structure methods so that it's hyper durable. We're talking apocalyptic bomb shelter durable. And it'll last for many, many centuries without maintenance. And it also has a much lower labor cost per square foot. So you're building homes often, and that means you have a faster doubling time. So if one group of people build some homes, then they can move more people in to also, now you have twice as many builders building homes, and then more people move in. You double on a faster trajectory, which means you rapidly produce a surplus of housing. So the concept here is that we're going to use tiles, long rectangular tiles that have notches in them. And those notches let you link them together like the four walls of a box. There'll just be a few feet in each direction. And these boxes are laid as the perimeter of your structure. You'd want the outer perimeter, and you also want interior walls as flanges, kind of a support wall, kind of like the walls of a grapefruit. So once you have these boxes laid out, you're going to take a pressure washer, 10 atmosphere water jet, and you're going to start digging the soil bed and clay bed inside the perimeter of your structure. The area where you'd be living, you're actually going to dig it out with a pressure washer. And that mixes the water and the clay and any sediment and gravel and sand into a slurry. And you have a dredge pump that's pumping that slurry out into settling ponds. It's basically a kiddie pool. So as it settles, that slurry is going to separate the clay layer, the sand, and the gravel. And you can collect that clay, mix it, and pour it into those boxes. This is exactly the same as pouring Portland cement and gravel mix into formwork when you're doing a cement pour. So you lay a layer of clay in the boxes, and then once they've settled and solidified, you lay more boxes on top. And just like bricks, you got two boxes, and you're going to lay another box in between them. So it's a zigzag pattern as you go up the wall. And that means there's clay surface from the lower box that's in contact with the clay surface from above. So they're separated on each side by a tile, but they're actually clay continuously in contact as you go up. And once you've laid the support walls and dug out the center into a dugout structure, partially subterranean, then you can make a domed roof over it with H-shaped tiles. The H shape fits together. You got the top of the H here. There's going to be a separate H that links in, and on both sides linking in, and then those H's link in, and you build a tile arch. Once you have those H shapes with tiles, you're going to lay plates with little teeth that fit in between the gaps of those tiles. So the plates stick up just like plates on a drying rack. And those plates on the roof, you pour clay in between those spaces on the roof. So now you've got a clay layer on the roof, you've got a clay layer on the walls, they're all being held in place by support tiles. Once you have that tile structure with the clay and the dugout underneath, you can light a small fire inside. And the heat and the dryness is going to drive the moisture out of the walls and out of the roof. So you need to slowly dry out the clay. Once the clay is dry, then you fill the entire structures inside with flammable materials. Nothing toxic. This is just twigs and leaves. If you have cardboard or even used toilet paper, pallets, as long as they're not treated with chemicals. You just fill it up with anything that burns. You're going to have pipes coming in through the entryways that provide an intake of air. You're going to cover the windows and doors with large tiles so that the air is only flowing through the pipes and out through the roof. And you light it on fire. You light the building on fire. So that inside is going to be smoldering and getting hotter and hotter, and it acts like a kiln. And the clay that you're turning into brick and ceramic with this kiln heat is going to be much more efficiently converted into brick than if you were burning bricks inside of a kiln. You think about the kiln itself and the bricks inside the kiln. You have to heat the bricks, and some of the heat goes into the bricks, but most of it is hitting the walls of the kiln and evacuating. So if you make bricks in a kiln, you're losing a lot of heat. And we have to do expensive systems to recirculate that heat. So there's things like tunnel kilns and different types of kilns for making bricks. So if your brick is the kiln, you're kilning the walls, then you have a much more efficient conversion efficiency. It takes very little energy in flammable materials to make your brick. And you're using local biomass that's renewable instead of using expensive and potentially toxic carbon sources that are coming from the ground. So this is a better way to produce the brick that you're building your house. It requires much less of a carbon footprint and fuel cost than just laying your concrete skirt for the foundation of your rancher. And the other thing to consider is that because you're digging out the center of the structure in kind of a step ladder pyramid, like a ziggurat but upside down, you only need the walls to be a little high. You don't need the walls to be full height, and the arch dome means you get a high ceiling without much wall material. So it's a thick wall that only goes up a meter or two, and your structure on the inside dips down, and then you have an arch dome above. And so just bare estimates on labor rates for the operating the pressure washer. I do recommend that you look up pressure washers being used to dig around the roots of trees that they plan to uproot. If they plan to do a tree removal, pressure washing around is way easier than any other method. Very fast, 10 to 15 minutes, and you've dug up all the soil around the tree roots. So pressure washers, without a lot of effort, you're able to excavate a lot of material without having to push a shovel around gravel, without having to deal with hard packed clays. It just cuts through everything. And the dredge pump pumps at high volumes into the sedimentation pond, where you rapidly separate clay from sand and gravel. So filling up the tile formwork and building out that layer and pressure washing, and then operating the fire, it's minimal effort, minimal labor for the number of square feet that you construct. Even a generous estimate of how much time it would take is about 2 square feet per hour of labor. So you could build a full-size family home in 1,000 hours. And if you're valuing your labor at $40 an hour, you normally make $80K a year, then that home only costs you $40,000. And the other factors to consider are that when you're firing it, there's going to be a layer just inside of the tile that's baked into ceramics. It's a thin layer, but ceramics are more than a dozen times stronger than concrete. Residential concrete is 7 to 10 megapascals. Ceramics is in the hundreds. So even with a thin layer of ceramic, you are many times stronger than a concrete or brick structure. Brick walls in particular, you have brick, which is pretty strong, but you have the mortar in between the bricks. And the mortar has to be weaker than the brick. If the mortar is stronger than the brick, then any settling will cause the bricks to fracture, and you'll have a traveling fracture of the structure. The whole brick wall falls apart. So mortar always is weaker than the brick. And because you have these layers of mortar between each brick, the total brick wall is much less strong, much less stable than solid brick, or especially solid ceramic. So this structure is very strong. You could be walking elephants on top. And then after that thin ceramic layer, you have a thicker layer that's baked to terracotta temperatures. And terracotta is basically the same as brick. It's a water porous, solid material. It's lower density. So the terracotta layer, when it rains, is going to absorb the rain. And ceramic filters the rain as well. And it holds the rain. And that's important because the outermost layer would still be clay. It didn't get hot enough to ever turn into any kind of ceramic. And that outer layer is where you plant your vertical garden. You have an herb garden growing on the surface, like a chia pet. So it's fed by the drip irrigation effect through the terracotta, exactly the same as an Oya jug, OLLA, which are highly efficient soil penetrating irrigation methods. So the way you're able to plant into that surface is because these tiles are not a solid plate of tile. If you have that thin plate of tile, then it has what's called a low transverse rupture strength, which means if you push on it, it'll crack. So instead, you want the tile to have thickness, and you want that thickness to not use up a lot of material, and you want it to have gaps. And the easiest way to do that is you have a clay extrusion. Use an auger to churn clay and push it through a die. It's the same way they make macaroni. And so as it pushes out of that extruder, it's going to have a lattice of support structures with holes in the lattice. And you're going to extrude a long block with all these lattices, holes going laterally. And once that block has begun to set and cure, once it gets leather hard, then you're going to cut it into tiles that'd be a few inches thick. And by increasing the thickness of the tile, you multiply its transverse rupture strength many times. It's the square of the thickness. So it's much less likely to fracture, and it has holes in it that you can plant into on the exterior. And that's also the pathway for heat to penetrate on the interior. And when you're done with your structure, the flooring is also baked ceramic. So you've already built in your foundation. And the other aspect is that before you have burned the interior and kiln-fired it, you want to spray the inside walls and ceiling with glaze. And so by spraying the inside with glaze, when you kiln fire it, now you have glazed pottery walls, which are pretty. And they require no maintenance. They're easy to clean. And that helps with water penetration. If there are any cracks or leaks, you can just daub it. You stop the crack. You don't have to worry about the structure rotting. You don't have to worry about water damage. You don't have to worry about fire hazards. You've already made it solid clay or solid ceramic. And so those structures, because they require such little labor to produce so many square feet, that means you can have a small crew build housing and then move in more crew. And then that crew builds more housing and moves in more crew. And that crew builds more housing and you get an exponential doubling time. So it would only take half a decade to go from a few hundred crew members to millions of units of housing. Literally. Millions of units of housing. We could completely cure the housing crisis. And that ability to rapidly produce cheap housing that's durable would mean that you don't need landlords anymore. Banks that are surviving on inflated mortgages, real estate enterprises, all those hedge fund investment bros who are exploiting renting. They rent out suburban homes now. They all go away. And your rent and your mortgage is literally trillions of dollars per year in just this country. A large portion of our entire economy is going to people who never did any work. You're just handing them most of your cash. So all that money that you save would be going into disposable income. You can buy more stuff, and you can invest and save for retirement. And that's how you rebuild a middle class. That's how you get a middle class again.